in the equation, the plus b versus the a, but it was still the what? It was still the y-intercept, wasn't it?
Okay, so here it says, what do you notice about both graphs? Well, they're both increasing, right? Which we just kind of defined as growth. So they increase, also known as growth. And I think I gave you guys some extra ones yesterday about it approaches the zero limit. We'll get into that later too. I'm just using those words so you hear them. So when we do get there, you're familiar with that language. Okay, second page. Graph the following. So this is the same thing, but it's decay because our b value right here, which I'm going to go ahead and rewrite this on every page so you guys can remember. Our b value is less than 1, so it's what? Decreasing, so it's decay. What's my initial value?
1.
Which is also what?
Y-intercept.
We're just gonna mark that. Okay, and so how would I grow? How would I draw decay? So this was growing.
The other way.
So-
The other way now.
No, the other way.
Like, flip it.
Sorry, I saw you pointing this way, so I thought you were saying to go that way. So this way.
Yeah.
All right. And it's approaching 0. Again, I'm using that lingo because we're going to get there eventually, okay? So it approaches 0. It's coming down.
Also, don't forget, when we talked about linear, we look what? Left to right, correct? That's the same thing. From left to right, we're going what? Down. It's a decay. From left to right, the other one was going what? Up. It's a growth. It's not really much different than looking at it from a linear, except for that's just a curve, right?
Yeah, this line, and you can
Okay.
see it's lower too.
Yeah.
So if you cover up this side of the graph and it's going that way, you know it's up, but it's going this way, so it's down. So it's decay. Okay, so this one too. What's my initial value?
2.
And that's my what?
Y-intercept.
Good job. And it's 0.4. It's less than 1. My b value is less than 1. So is it growth or decay?
Decay.
Okay. So would it look something like this?
Yeah.
And it's approaching 0, which we're going to get there. Okay, so what do we notice about both of these graphs?
Both decay.
They're both decreasing.
And they're both going to
Decay.
slow down.
Okay. So I'm just going to do this because we're going a little, and it's decay. Okay, compare equations 1 and 2 with equations 3 and 4. What did we discover? So look back on your paper. So what determined if it was decay or if it was growth? What value did we look at?
The b value.
The b value. Thank you. So the b value in growth was larger than what number? And in the b value in decay was less than what? Okay. Do you guys think that b can be equal to 1?
No.
Do you guys remember why?
Because you can't raise an exponent to 1.
Exactly, and it's either always increasing or always decreasing. So 1 raised to like,
Wait a minute. Yesterday you told us A is greater than 1 and
It's because we switched it. Yeah, we switched it around.
That's just gonna mislead.
remember how I said you can remember the equation a, b, x, a, b, c, which is actually a different letter, it's k, but we'll get there. So it just goes in order, a, b, x. I think you came up with some silly.
Yeah.
Didn't you come up with like some silly saying?
B-A, B-X, alphabetical.
Yeah, something about xylophone.
Always being silent.
Always
Always bring your
xylophone.
I said whatever worked for you.
Okay, A, B, C,
You were
Y.
hyper yesterday. Okay.
I was like really into this one you're saying.
Hey, let's keep going. So again, this is a little bit of repetitive, but exponential growth functions, when a is greater than 0, the graph will be decreasing. What will b be
Wait,
for growth? Greater than 1. Okay? So same thing here. A is greater than 0 when b is less than 1. So that's just something you have to memorize, which I think is pretty easy. If it's less than 1, it's decreasing. If it's more than 1, it's increasing. Okay? do it together since we kind of already. Tell whether the following graphs represent growth or decay, exponential growth or decay. Well, what did we say? Look at the right sides, right? Quadrant one, decay. Because what?
Because it's going down.
Because it's decreasing, going down. This is what?
Growth.
Because what?
It's going
Okay, does everyone see how that's super simple? Nobody should miss this on the test, correct? Everyone understand that part?
What's the initial value for both of those graphs? Okay, so they both start at 1. Well, you got it on your paper. Why aren't you looking on your paper?
How did he find what the initial value was? What did he look at?
Because it runs down.
Y-intercept, right?
Tell whether the following equations represent an exponential growth or decay. Again, pretty simple stuff. What do we look at?
The
B
B value.
The B value. Okay, so which one's my B? This is, remember we said 1,
3/2.
ABS. So here, 3/2. Is that bigger than 1?
Growth.
Yes.
So we just simply write grow. What about here?
Growth.
Growth.
Grow. Because it's bigger than 1, correct?
Growth.
Growth.
What about here? Grow. Because it's bigger than 1.
Decay.
Why? Katie?
Because it's 1/4.
Okay.
And that's decay.
Which is decay.
Okay. And remember when we said there's no value, there doesn't really seem to be a value here, right? So
We just assume that
yesterday
it's
people
equal.
asked,
Yeah, it's a
well,
1.
why would we assume that it's 1? Well, have you guys ever done any exponent raised to 0?
No. Yes.
Any
No,
number,
we
sorry,
haven't.
any number raised to 0, what does that always
One.
equal?
That's
1.
I
So
would
if
never
x was 0, remember input output tables from y equals mx plus b, you
Yeah.
put a number in. So if you put 0 in for x, it would equal 1. So that was y equals 1.
Gotcha.
Okay? But if there's not a value there and there's nothing else on the equation, you can always just know it's 1 just by looking at it. Okay? That was just like a little backstory of why it's 1. Okay. Give 2 examples of each. Here I just said you can make up your own equation. What did you say? Can I use 720 or something like that? Yeah, you can use whatever. Your initial value can be any number. But it can't be what? Or, okay.
One.
So, or it's not going to be negative, is it? Are you going to start with a negative number?
No.
Like, remember how we were kind of like talking about like bank accounts?
Yeah.
You get interest rate?
They have
And you're gonna put in something bigger than 0, right? To let it grow. So that's a good way to look at it. If you want something to grow, like your money to grow, you're not gonna be like, oh, here's negative $5. No such thing, right? Okay. So now we're gonna get into the parts. We've already gone over this, so we should fly right through this, and you guys can work on your homework assignment in class. So the faster we go. For the people that weren't here yesterday because of the field trip, does everyone understand this so far?
Yes.
Yes? Okay. Alright, so what is A equal? The initial value. Thank you. And we also said it was our y-intercept, right? Okay. If B is greater than 1, we've said this about 500 times now, it's growth. Thank you. And then B, so here the
Growth factor.
Growth factor, thank you. And that's what it is. And our R is going to be our growth rate. So if you had a question, which you're going to, it's going to say, what is your growth rate? There's an equation that you can use to
B
find it.
equals 1 plus R.
Okay, that's, yeah.
R equals
Thank you. R equals B minus 1. And that puts it in rate form, okay? So this is just manipulating the
How could
equation.
we remember the R?
Okay, I want you to think about it.
I'm sorry, yeah.
Let me, because in thinking about this, we can tie it back to percent. Okay? Remember when you were doing tax? You had that, right?
Yeah.
Everybody, I don't have
Find the,
everybody's attention.
find the tax.
I can tell you right now, I don't have everybody. You need to stop and focus up here. Okay? If I said 5% tax, I said the easy way to do that is to multiply by 1 because that's the whole price, correct? Plus the tax, which is 0.05. So we're doing 1.05. That's what we're multiplying by. When you have a growth, you have to keep the initial value, which is 1. Times 1 is going to give you that initial value, isn't it? But then it is growing by that rate. So let's say you start at 5 and you have let's say this rate is like times 2. Okay, times 2, right? So what you're going to do is you're going to have that 1 and then you're going to add times 2 to that. See what I'm saying? When you do 2 right here with your growth rate, let's say it's 2 to the x, right? You're multiplying by 2 every time, correct? You're adding that back to it, just like you're adding this tax back to the original price.
When did we
You're
do tax?
adding this growth rate, back to your initial value, correct? What about decay? Are you adding it back?
One
or are you
minus
actually, when you decay, are you subtracting it?
Subtracting.
So B right here, but then you're subtracting that. You're actually subtracting that. I mean, it's not quite the same, but if you think about decay being subtracting, but growth being adding. Okay, so if I'm going to grow, my B is going to be equal to 1 plus the rate, whatever I'm increasing it by. Okay, but if I'm going to decay, then my rate is going to be equal to B minus that 1. Okay, rate is going to be B minus the R. Okay, so you kind of think about it that way. I mean, it's not perfect, but if you think about it as growth and decay, it might help. I'm not saying you have to think about it that way because sometimes we have our own little analogies that might help us, but that might be something that would help you. Yes?
So you said that it would be -1 when it decays, so it would be +1 when it's growing? No.
Okay, well, right here we're talking about the what? The growth factor and the growth what? Rate. So if you want to find B is going to be 1 plus the rate. But if you want to find R is going to be what? B minus 1. Another way to think about it this way.
Yeah, but you
Can
said
you
that.
just think about this one? Is it easy to remember that?
To what?
That B, which is your growth factor. Your growth factor, B, is always going to be 1 plus the rate. If you can remember that one, can you use inverse operations to do this one?
But you said that it was -1 when it was decaying.
No, you can think about it like that way. It's not quite the same. Look, just remember this. If you want to know your B, you can do 1 plus the rate. Does that make sense? When you're adding the rate to the initial value, or the 1. Okay? Now, once you know this one, you only need to know 1, right? How did I get this R equal? Didn't I just solve for R? What would you do? You just subtract 1 from both sides, right? So R is equal to B minus 1. Didn't that just come from this?
Yeah.
This is the original. If you just remember that 1, you can rewrite it and solve it for R. That's all you got to do. Solve for R. Okay? So if you can remember B equals 1 plus R, then it should be easy to remember that R is just B minus 1.
I can't remember either one.
Why not? Okay, B is your what? Growth factor. Okay, your growth factor is going to be what you started with. Okay? If I multiply by 1, don't you just start with that? And then you're adding the what? The actual rate at which you're doing it. That's all you're doing. 1 plus the rate. Okay, B is equal to 1 plus the rate. That's all you got to remember. And then you know what R is. If B is 1 plus the rate, then R has to be B minus 1. Understand?
Okay, we're gonna go over it.
I mean, we're still going to be using it more. Maybe it'll make more sense when you
He's just
actually use it.
manipulating this equation to tell you
So you
to
don't
find the rate of growth.